So the last thing I want to go over is how can you tell if a function is quadratic just by looking at the equation. So I got 5 equations right here, and we're just going to identify whether they're quadratic or not. I'm going to give you my insight on whether it's quadratic or not. So here's what I try to look for. Is the highest power a squared power? If the highest power is squared, like if you have t squared, that's the biggest power, quadratic. Okay, if you have an x squared, it's quadratic. That's the highest power. If you have anything lower than that or anything above that, like an x to the third power in there, not quadratic. Okay, or a t to the power, not quadratic. Okay, so we're going to look for things like that, but sometimes you have to simplify it out. Let's just take a look at the first one right here. The highest powered is an x squared right there. So is it a quadratic? Yes, it is. Why? Because you have an x squared as the highest power. Okay, highest power. Okay, so let's move on to the next one right here. We got 1/4 t squared, and then we got a t, and then we got a constant. What's the highest power? This one right here, it's squared, therefore yes, it is a quadratic because t squared is the highest power. Okay, let's do another one here. Here we got t squared minus t squared times t plus 7. It's tough to tell from this one. We had a t squared right here, but we got to simplify this out before we go any further. So let's take this negative t squared and distribute here and see what we get. So I got t squared minus, actually we'll distribute with red just so you can see what I'm doing, minus t to the third, because t squared times t is t to the third, minus 7t squared. Okay, so when we look at this, what is the highest degree term? Well, yeah, I know we can simplify this by bringing it together, but yet the highest degree term is this negative t to the third, and that is not t squared, therefore this is not quadratic. Not quadratic because t to the third is the highest term. That's why it's not quadratic. Okay, let's do another one here. Here we got 3 minus s. Is that quadratic? Well, no, it's not quadratic. The highest degree term is s. So therefore, because s, there is no s, maybe you could put there is no s squared term, right? And here, the last one. Here, this one. These are tricky. Let's take a look at this one. Here we got, if we didn't have this bottom right here, if we didn't have that, right, we could say right off the bat, this is quadratic. Our highest degree term is x squared right there. But we have this x plus 1 dividing it. And so this is what you got to think about in this situation. What's the highest degree term on top? Well, the highest degree term on top is 2. See this 2 right there? And what's the highest degree term on the bottom? Well, in this situation, there's a 1 right here, so the highest degree term is 1 on the bottom. And therefore, you know that this is not a quadratic, because this, for surely, that one of the degrees, this degree on top, the 2, will cancel out 1 on the bottom. So really this is almost, not exactly, this is almost linear, but some weird stuff's going on with this. So in this situation it's not, and you could go to a situation like the graph is not, you could graph this, maybe graph it. The graph would not be quadratic. So graph is not a parabola. Okay? So that's another way to think about that one right there. So anyway, those are ways, or what I think about when I am trying to figure out if a function is quadratic or not, things that I look for. Okay? I think I got these all right. Not, yes. Okay, we're good.